lot of progress on recently, so I'll talk a little bit about that in a few minutes. Let me talk a little bit about the course experience in this format. The first is the flexibility provided to students by having video as the primary mode of instruction rather than being placed in a classroom with 200 other students being taught in the same pace at the same time. So this is what the experience looks like. Oops, what happened here? Yeah. Try one more time.
These four things:
okay.
Prospect theory, hyperbolic discounting, status quo.
So this is one of the videos in one of our courses. You can see there's subtitles actually in multiple languages. When the video hits the yellow notch, the students get asked the question, they answer the question. They're immediately given feedback as to whether they're right or wrong. They get to try again. There's an optional explanation. Now, I'd like to point out two aspects of this. First of all is the flexibility of the student to watch at their own pace, at their own time, pausing, rewinding if they need to get the material better. The second is the fact that this is a much more interactive experience than your typical face-to-face class, because the students, when they're asked a question, it's not just the one smarty pants in the front row who answers the question with everybody else still being zoned out or on Facebook. It's everyone has to answer the question, and therefore it's a much more interactive and engaging experience than your typical, certainly your typical large lecture class. Now, the real learning, however, doesn't just happen from students passively watching videos. It happens by students doing work and getting meaningful feedback for it. And how do you do meaningful work when you have to grade the work of 100,000 students? And so we've adopted two techniques for this. One is to have the computer grade the work, and the nice thing is that I'm not going to go into the details, but computers can now grade a fairly deep and meaningful range of work that transcends your generic multiple choice, which is what everyone thinks about. And I'm happy to answer questions on that. You can grade math, you can grade computer models of physical systems, you can grade Excel spreadsheets of marketing or financial models and so on. All of that can be graded automatically by a computer. Now, there is an aspect of computer grading that many people don't think about the first time they think about grading. They just think about this as a scalability mechanism. But perhaps even more importantly is the fact that it allows students to achieve mastery. Because when students get immediate feedback as to whether they're getting this or not, as opposed to 5 weeks after they learn the concept, do the homework, and get the graded homework back, it immediately turns the learning process into a game. Students say, I only got 70 out of 100 on this, I can do better. And then they resubmit. And you can see those statistics pretty clearly in this chart, for example. This is pretty typical. The blue bars is the score distribution for the initial submission of an assignment. The green bars are, for that same assignment, the final submission after the students have had a chance to reattempt it. And you can see that most students just naturally gravitate towards achieving effectively a perfect score on this assignment. Now, the question you're probably asking is, well, is that a better learning experience, or are they just doing trial and error until they eventually get a high score? So the answer is we've done some data analytics on that recently, and it does seem to help. For students who performed equally well on the initial submission of problem set 1, the ones who did mastery learning performed better also on problem set 2, not just in problem set 1. So it actually does help the learning outcomes in subsequent assignments as well.
How did you figure that out?
We looked at the initial, okay, there's a bunch of statistics that went into this. We did a predicted score for the student on problem set 2 based on all of the demographics and everything that they did on problem set 1. That was the predicted, and the students who did mastery learning, their actual was higher than the predicted, whereas for the ones who didn't do mastery learning, their actual was the same as the predicted. So I can go into more details in the regression.